Right, this one is on Venn diagrams. It's been asked to do this. Right, for GCSE resit. So these are not easy, by the way, Venn diagrams. Right, first thing to know about Venn diagrams is that this is when we're asked to work out a the probability of something happening. So there's always a P. Now, when you've got, see these circles down here, when you've got A, it means it's in A. When you've got A with a little dash by it, it means it's not in A. So it's the opposite. Everything that isn't in A was that. Now, all probabilities, for this first one, all probabilities add to 1. And if the probability is A is 0.9, then the probability of it not being A is the difference between that number and 1. So it's 0.1 is the probability. Now, shade the region that represents A, this symbol, and B. Now, this symbol means and. Yeah. So we need a region that is both in A and in B. So it's A and B. Not all of A and all of B, but only the bit that's in A and B. And that's this bit here in the middle. Now, we've got a different symbol now. And this symbol is OR. Say we could, and this could be, let's just go back, this could be A and also B. Yeah, that's better. Have the also. So this is in A and also it's in B. This means A or B. So it's a region where it could be in A or it could be in B. Yeah, or it could be in both. Yeah, so that's all of this, everything. Not outside the circles, so everything, so anywhere in here where I'm shading now is either, yeah, either, yeah, either or, yeah. So it's either in A, so what could we put there? Either in A or in B. So it's can be either or. Now, let's have a look and see what we've got next. Now, it gets more tricky now, because this is, this, if this was this, oh, hang on, that would be either in A or in B, which we know is all that in the middle. But because we've got the not, so it's either not in A or it's not in B. So anywhere that is not in either A and B. Oof, that's the bit round the outside. These signs are not my favourite, this one, but never mind, we can still do them. So roll the way around here. That is not in A and it's not in B. Yeah, so it's the reverse, the sort of negative of what's in either A and B. So it's the opposite way around. Now here we've got a sign that is and. So we have not in A and also in B. So we want everything that's in, I'll do the B first, everything that's in B and everything that's not in A. So that's all the way, all this stuff around the outside. These are mind-bogglingly crazy Venn diagrams. So there's a region that it's either not in A or it is in B. Whew. So how many of these we got to do? Right, this one here. This is A. So this is A. It's in A and also not in B. Also not in B. So everything that is in A that's everything that's in A and also not in B. Well, not in B you'd think that would be everything around the outside, but it's got to also be in A. So this region here is in A and it's also not in B because it can't be around the outside, otherwise it wouldn't be in A. Now we've got a probability one now. Okay, so what we've got 40 students were surveyed. So the left-hand circle are the people who went to France, the right-hand circle are the people who went to Spain, and 10 people visited both France and Spain. Use this information to complete the Venn diagram. So we'll have 10 people that went to both. Now, if 20 have gone to France, that will include those 10 that went to both. So there are 10 people that only went to France. And if 15 visited Spain, that will include those 10. So there are 5 people that went to Spain altogether. Now this only adds up to 25, but there are 40 altogether. So some of the students didn't go to either of those places, which is the difference between 40 and 25, which is 3, 5, 1. So 15 people go down here in the corner because they didn't go anywhere. Right, number 8. Number 8. What we're going to do for number 8. So, out of 50 people surveyed, 30 have a brother, 25 have a sister, and 6 have neither a brother or a sister. So, we'll put the 6 that doesn't have anybody in there. Now, we've got 55 people in here. So, how many's there? 30, 55, 61 there. So, let's add these two together. People who have brothers and sisters. So 30 and 25 will be 55. 55. Now, there's 55 people. Now, how do we know how many people are going the both that have the brother and the sister? So we've got 50 people surveyed and 6. So there are 50 people surveyed altogether. So we've got 55 here, and so there's a 5 difference there. So there must be 5 people that are in both, but we've got 6 here. So 5 plus 6 is 11. So we've got purely brothers and purely sisters. Looks as though there's a 5 overlap, but we take the 11 as well. So if we do 55 minus 11, that equals 44. So we've got 44. So 5 and 6 are 11. So 5 and those 6. There must be 11 in the middle somehow. Now, the people who have brothers are 30, which include the 11. So there must be 19 in there. 25 have a sister, which is including the 11, so there must be 14 there. So that adds up to 30, 44, 50. Yeah, that adds up to 50. So that's very difficult, these. Right, okay. Now, 50 people are asked. They like tea, coffee and milk. So, we've got we've got a triple here, yeah. Call that tea. Hang on, let's have another big circle there. We'll call that coffee, and we'll have one over here, and we'll call that milk. Wow. Now, 50 people like at least one of the drinks. All 50. So there's no. So if we surround that with a there, all 50 people like drink. So nobody likes nothing. Yeah. 19 people like all three drinks. So we're gonna have 19 people in the middle. Yeah. 16 people like tea and coffee, but don't like milk. So 16 people like tea and coffee that don't like milk. Aye. Let's do this. One person only likes milk. So there. 40 people like coffee. 21 people like coffee and milk. So, goodness me. Let's have a look. What's the next one to do? 16 people like tea and coffee. So this is shared. 16 people like tea and coffee but don't like milk. Ah, right, the milk goes all over the way. So those 16 people have got to go in there because they like tea and coffee but don't want to be in the milk thing. Right. Now, can we fill in the rest of this tea thing? 24 people like tea and milk. So that 24 people like tea and milk. Right, so we've got 19 here that like tea and milk. So 24, take away the 19 is 5. So 24 people like tea and milk. Right, now, how many of this? How many like tea altogether? What have we got? Like 21 people like coffee and milk. 21 people like coffee and milk. So we've got 19 there. So there must be another 2 in there. Right. Now, 21 people like coffee and milk. So we've done that bit. 40 people like coffee. Right. Here's the coffee. So 16, 26, 35, 37. So there are 3 people here that like coffee. Now, we were asked 50 people, so let's add all this up together. So I'll do that again. 16, 26, 35, and that makes 40, 40, 46. So there's 4 people left that just like the tea. Right, Sammy asked 60 people. Is this another triple one there? Oh, gosh. Sammy asked 60 people which sports they like. Rugby, football and cricket. Okay, again. Rugby, football and cricket. Okay. Now, we've got to find out how many like neither of them. Yeah, so that's going to be our bit around the outside. How many like that? So, 8 people like all 3 sports. So, we're going to put 8 people in the middle. Right. Rugby. 19 people like rugby and cricket. 35 like football. So we've got to do, these are in a group, aren't they? That just tells you the totals. So if we can find something in here. So 17 people like rugby and football. So we know that that's got to be in this bit. And we've got 8 of them. Therefore that will be 9. Yeah. 13 people like football and cricket. Football and cricket is in this. We'd know there's 8 in this, so the difference between 8 and 13 is 5. So how many people like football altogether? 35. So we've got 17 and 22. 35 from 22 is 13. Right. Do we know about rugby and cricket? 19 people like done that, haven't we? Yeah, I think. Yeah. 19 people like rugby and cricket. Now we know we've got 8 of them there. So that will leave 11 that go in there. So how many people like rugby? 30 people like rugby. So we've got 28 of them, so there must be 2 up here. And how many people like cricket? 27. We've got 19, 24, and there's 27, so there must be 3 people down here. Right, add all this up. 2, 11, 24, 29, 37, 48, 52. 52. Ooh, have I got that right? 52. I don't think I've added them up right, have I? So 2, 9 is 11, and 13 is 24, and 11 is 35, and 8 is 43, and 5 is 48, and 3 is 51. 51 accounted for. There are 60 altogether, therefore there must be 9 people in there. Hi-ya-ya. Okay. Even numbers between 1 and 31. Okay. So we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Okay, all the even numbers between 2 and 10. So anything that's not in these 2 sets will be on the outside. So we've got 2, we've got 4, there's no 6, so 6 goes on the outside, so we'll cross that off. We've got 8, 10, there's no 12 in there. 14, yes, 16, 18, no 20. 22, no 24. 26, no, there isn't one of those. And there's a 28. Right, so what did I go? 2, 6, 12, 20, 24, and 26. So all of these numbers are now in these. These are the ones that are left. So are there any that are in both? So 8 is in both. So that's there. Cross that, cross that. 18 is in both. Cross that, cross that. 22 is in both. So cross that out, cross that out. So these must be the ones that are in A alone. So 2, 4, 14, and 28. And these one that are in B alone is 10, 16, and 30. Now, we've got a probability question now. So, what's the probability of the number set being in A or B? A or B? A or B. So it's either A or B, which is basically all the ones inside the circles, because they're either in the A or they're in the B. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 of them. Out of a number is chosen random from everything. Now, how many numbers do we have altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's 10 out of 15. Right. Here is a Venn diagram. Here is a Venn diagram. I suppose, see that 10 out of 15? I suppose you could have simplified it, couldn't you? What was that? 10 out of 15. 10 out of 15, divide by 5, 2 out of 3. You could have done 2 out of 3, but I never bother. Never bother, not with these. List all the properties that is in A and also B. A and also B. Everything that is in A and also in B are these three numbers here in the middle. So we've got 3, 1 and 8. Now, find the probability of a number chosen at random. Find the probability that it is in B, either in B or in C. Everything that's either in B or in C. So all of these are in B, all of these are in C. So let's count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of them. Out of all of them. Yeah? That sort of chi letter, the Greek letter, it means everything. So all the numbers, how have we got? So we know there are 10 there, and there's just 2 more there. So it's 10 out of 12. Got some more. Got some more. Right. These are really complicated Venn diagrams, yeah? Right, okay. So complete the Venn diagram to represent the information. Odd numbers less than 30. Okay. So 1, 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, 29, less than 30. Okay, so everything that isn't in these three sets must be outside. Okay, so 1 is, 3 isn't, so that's the 3 outside. So 3, 5, 7, no 9, so there's a 9. 11, 13, don't have a 13 either, so that's there. 15, 17, 19, 21, there's no 21 there, so we'll have a 21 outside. 21, 23, 25, 27, 29. So we've got 4 numbers around the outside. Now, what are we going to do? Let's find something that is in all 3 of them, yeah? So the number 7 is in all 3 of them, and that is the only one. So let's cross off 7. Now, the number 1 is in A alone. The number 5 is also in A alone. Number 7 we've done. Number 9 we've done, it's on the outside. Number 11 is in B on its own. 13, yeah, that's outside. 15 is in B and C. So something that is in B and C is there. So that's the number 15. The 17 is just in C. "19" is just in C. 21 we've done, that's outside. 23 is just in A. 25 is just in C. 27 is just in C. And 29 is in A and B. 29 is in A and B. So we don't get anything that's in A and C. Okay, so find the probability that the number is a member of either A or B. And A and B. So it's got to be in either A and it's got to be in B. So anything that's in A and B. So all the ones in A are that 1, 5. All the ones that are in A. Oh no, it's not or, is it? It's and. It's got to be in A and B. So the A and B is this bit in the middle. So there's 29 and the number 7. So there's 2 of them that are just in A and B from everything. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers. 15 numbers. Right. Okay, that's that. So that's Venn diagrams for your delight.